Hello and welcome everyone. Thanks for joining us for today's webinar. My name is Julia Becker with the content marketing team at FreightWaves. We're happy to present today's webinar in partnership with Locomation. Autonomous trucking has made headlines for years, with a few updates on true commercial deployment until now. Locomation expects to be the first company to deploy autonomous trucking technology safely, legally, and routinely across the United States in 2023. As we discuss these trucking's key safety elements, I'll be joined by Finch Fulton, Vice President of Policy and Strategy, and Michelle Chaka, Director for Safety Assurance and Standards. We'll also have a live Q&A with our speakers following our discussion. But before we get started, I'd like to cover just a couple of items. First, if you have any issues during the webinar, you may reach out to our team via the audience chat function, and we'll be in touch to assist you. If you have any questions for our speakers, you may enter those in the Q&A box also in your console, and we'll answer as many questions as we have time for at the end of our presentation. We'll also be sending a link to the recording of this webinar tomorrow if you'd like to view it on demand or share it with your colleagues. At this point, I'll go ahead and turn it over to Finch to lead today's discussion. It's great to have you here today, Finch.
Thank you very much for having us. So I think we want to start first with some quick introductions of myself and Michelle Chaka. We're both very pleased to be here on behalf of Locomation. We've got a really good story to tell. Michelle, do you want to start?
Yeah, sure. Thanks, Finch. So I am the Director of Safety Assurance and Standards at Locomation. And so what does that mean? I focus on developing the evidence that we need to prove that our system is safe and make sure that we continuously monitor that system during the on-road testing that we're doing today and eventually in deployment and operations. And before coming to Locomation, I had the opportunity to work at Virginia Tech Transportation Institute, where I researched what automated vehicles may need to do to demonstrate that they are safe. And prior to coming to VTTI, I spent 20 years at Ford Motor Company working in a whole gamut of safety items, everything from crash safety to cybersecurity to automation. So if you name safety, I probably touched it when I was at Ford Motor Company. So I'm really happy to be here to talk about what we're doing at Locomation and why our system is safe. So I'll turn it over to you, Finch.
Perfect. So as we were saying, I am Finch Fulton. I'm the Vice President of Policy and Strategy at Locomation. I spent some time in the U.S. House of Representatives, the U.S. Senate, spent some time working on the state and local integration of technology, and then I actually went to the U.S. DOT under Secretary Elaine Chao, where I spent 4 years there as the Deputy Assistant Secretary for Policy, and I got to work on all the fun, shiny objects in the building, everything around automated vehicles, drones, Hyperloop, commercial space launch and reentry, data efforts, and even time itself. So it was good fun. But because of the work on autonomous vehicles, I got to work on all the policy, all of the research. Frankly, a lot of the research that Michelle led ended up being things that we talked about a lot and spent a lot of time on. So all of her work at Virginia Tech came up to the department, and it shaped all of our efforts going forward. So as I was leaving the department after the election, I gave a speech about what sort of automated vehicle deployment model would make the most sense based on all of the research, policies, and regulations coming our way. And essentially one of the members in the audience was the CEO of Locomation, and he essentially told me that I described his company. So fortunately, that got me a job. So it was a very good accidental job interview. But that led me to Locomation, where I've been since February of 2021. So Locomation is an American autonomous truck technology company based in Pittsburgh. We've got over 130 people, probably approaching 140. And we are a little bit different. First of all, it's a combination of locomotion plus automation. So the difference in our name is usually enough to get people tripped up. But also, as we talk about how people think about autonomous trucking and the market as a whole, our founders have started out being a little bit different than everybody else. So they do come from Carnegie Mellon, which is not uncommon for autonomous truck makers. But back in 2018, when they saw all of the investments flowing into the market for automated vehicles, everybody was focused on robo-taxis. And for them, they were looking at this, and robo-taxis may get 10 times the hype of an autonomous truck, but autonomous trucking has 10 times the market. And so they knew that's where things should be focused. Also, because of their decades of experience and everything from working with DoD on some of their off-road convoy military technologies, to the DARPA challenges, to Mars rover itself. They had decades of experience, and so they understood all of the barriers that lied ahead for level 4 fully driverless technology. So they thought about a different approach, one that's practical and actually viable for the trucking industry in the near term. And they did so by combining the strengths of the human and the machine together. So they had a market, trucking, and they had an approach. Next, they had to look at the problem as a whole and scope this solution to ensure that we would be addressing the market in the most realistic, fundamentally sound ways. In short, they had to understand the customer's actual pain points, not just what they hoped they'd be based on whatever technology they could come up with. So when you look at the trucking industry, first and foremost, there's a capacity problem. Either there's too much capacity so that the pay goes down, or not enough capacity so that truckers can't meet demands. There's high costs and low margins, which means with every fluctuation in labor costs or fuel prices, companies suffer and even go out of business. And there's certainly a shortage of drivers, but it's not because people aren't interested in truck driving. It's because of the poor quality of life that they currently have to endure. Consider this. Truck driving is the 4th most dangerous job in the country, but it's also in the top 5 for professions in terms of suicide rates. And this is linked to depression, loneliness, time being away from home weeks at a time, not to mention they make less than they expect and they budget for because of all the inefficiencies in the systems. The majority of their day is wasted waiting for loads or running deadhead miles to pick up the next load, continuously burning fuel and wasting hours, and contributing to higher carbon emissions and greenhouse gases. It is incredibly frustrating for them. So our solution was scoped to be a human-led, 2-truck autonomous convoy with the driver present for a number of reasons. Human drivers are trained to handle and understand normal as well as uncommon edge case scenarios. This lets us drive piece by piece into our approach to safety and our approach to the technology roadmaps, proving that our solutions work. And because of this, we aren't relying on smoke and mirror ways to address all of the challenges that the road can bring. We can answer them directly. Today, there's also federal guidance that says the driver of a truck can be a human or a machine, but there are still specific rules for the human driver around the safe operations of a commercial motor vehicle. For us, the human driver still handles all of these safety issues, so we're compliant with the regulations, which we're going to talk about in a minute. And without the regulatory barriers that our competitors are facing, our progression towards finishing that safety case and the ability to deliver these trucks to our commercial contracts safely and profitably is very realistic in the near term. So how do we do it? Well, our solution starts by looking at the deployment model and how companies and carriers are delivering these goods in the first place. By taking this model and optimizing it to prepare it for autonomy, we start by separating out the local activities from the long-haul activities. Now, these trucks can go from operating 6.5 hours a day on average to up to 22 hours a day, running these routes continuously and getting the drivers home every 24 hours, which keeps them happier and hopefully reduces the turnover. And if you're familiar with the economics behind autonomous trucking, you know that 2/3 of the cost savings are generated from the higher utilization of your most expensive asset, the truck itself, and it doesn't come from removing the human driver. So next, we bring on the human-led 2-truck linked convoy model, which is far more practical than a driverless system is today. With this, we are able to create a safer AV solution that can be deployed on today's roads without waiting and spending the billions of dollars it will take to figure out every single edge case that an autonomous truck will encounter in daily routine operations. This approach will allow us to deploy much sooner simply because we're using AV technology that exists today to augment rather than replace the human drivers. So we combine the common sense of the human to be able to handle any of the on-road situations that arise, which Michelle is going to talk about a little bit. We combine the human's benefits with the precision following an advanced AV system in a solution we call human-guided autonomy. So we're navigating real-world scenarios in a way that systems relying on mapping and deep learning or AI-only approaches just can't. And because our competitors require regulatory updates to remove the human driver from the cab, this creates a huge advantage in the market. And so because of this, and because of our realistic approach, And because of our pragmatism, we've looked at what's possible, and we're the only company out there with actual commercial contracts today, and hopefully more announcements soon in the pipeline. And that's something we don't believe any of our competitors can claim. And since we'll be able to deploy sooner than anybody else, and as we generate more road miles, we're able to train our systems so that we're continuously developing more advanced systems for the future, which allows our customers to capture more of the market and more of the opportunities when the technologies and regulations allow it. So we've really thought about our deployments, and we understand that we are going to be leading the vanguard, bringing unprecedented change to the industry. With the ability to drive twice as far, twice as fast, while delivering twice as many goods, all the while organizing the routes to get drivers home frequently, we can see significant benefits. In addition, the aerodynamic benefits of having a 2-truck length convoy leads up to a 22% reduction in greenhouse gas emissions and up to a 21% reduction in fuel burn. So the economic incentives are there to drive better policy outcomes, reduce pollution, and provide the best opportunity to lower the greenhouse gas footprint of long-haul trucking. It's nice when the policy outcomes get lined up with the economic outcomes that you want. And this is something that was done intentionally that will benefit the entire ecosystem. So what's our message then? Our message is join us in using the technology at hand to shape the future we want. We are on track to be the first company to safely, legally, and economically deploy in commercial operations at scale across the U.S. And that's something that others can't say. So we look forward to advancing the future of trucking, and we hope you'll join us. But as we think about these things, we should go deeper for a second into the regulations. So first, if you're not familiar, autonomous trucking is primarily governed by the U.S. Department of Transportation and the regulations with the National Highway Traffic Safety Administration, as well as the Federal Motor Carrier Safety Administration, NHTSA, and FMCSA. In general, when the federal government acts on any of these things, any of the regulations that impact autonomous trucking, they preempt states. If the federal government has taken no action, state law applies. The federal government has put forth guidance, and so if a state has taken no action, federal guidance prevails. So as we look at these things, all of the rulemakings for autonomous trucking have not been finalized across the federal government. They've taken steps and they've put out guidance, but right now there are many states where the provisions apply and you have to conform to. But most importantly, though, the regulations around all the other pieces that a human driver has to do in commercial motor vehicle operations, those are still in place today. So the federal government has said the driver of a vehicle can be a human or a machine. But if we look at the next slide, which we'll get to in a second, you can see all the different regulations that come into play that would prevent you from being able to remove the human. So first of all, and this is primarily important for our system, we're able to deploy in compliance with hours of service by using the rules that apply today for team drivers and that have existed for decades. Being able to use the sleeper berth and switch out human drivers, that's how we get up to 22 hours a day. Essentially, we have a team driving solution with 2 human drivers and 2 automated driving systems, and we switch places so that we can keep that convoy running nearly continuously up to 22 hours a day, based simply on the math for 2 human drivers. We can also deploy in compliance with all of these state rules and regulations, which is actually, there is a federal regulation saying you have to follow all the state rules, but that's important. And so we're able to deploy in a way that's compliant with every state across the country. There may be some rules that need updating, but in general, we're working on it. Now, when it comes to the rest of the regulations, I think it's important to understand how these come into play. So first of all, 3/4 of all crashes for trucks are caused by other road users. And this makes sense because truck drivers are trained professionals that do this as a job and take their safety very seriously. So you can create a perfect autonomous truck. Someone else on the road is going to hit your truck, and you have to be able to be ready to act in that case. So what happens if somebody hits your truck? Well, first, you need to be able to stop and pull over and put out warning markers at 4 and 40 paces around the vehicle within 10 minutes. And that 10-minute marker is very important. That's essentially the hook that means if you don't have a human that can be in that situation within 10 minutes, you cannot deploy, period. You are out of compliance, and there's no interstate loophole to where if you're only deploying in Texas, that this rule doesn't apply. It is a safety-specific rule, and so you have to be able to show a way that you can do this. So not only do you have to put out warning markers, you need to be able to engage the situation, work with law enforcement officers. You may need to call 911 to inform them in the first place, and ideally you're able to render assistance. This is something that truck drivers do today that not many companies have a plan for, but this is a safety critical area. And so if you're looking at proving equal than or greater than levels of safety, the ability to have a human driver call 911 is actually important. Now, you also will have to be able to do, if the situation is settled and there's law enforcement on the scene or first responders, law enforcement's going to need to be able to do an inspection of not only your big fancy truck that you spend a lot more on, but also that trailer that's probably a decade old. It's been beaten up, and it's a commodity. So you have to be able to do a walk around of your tractor and the trailer and be able to check and see if everything is in working condition. Now, if it's not, you have to be able to do something about it. And that's important when it comes to cargo securement as well. If somebody else hits your vehicle, you have to be able to check and see, has the cargo shifted? And you have to be able to do something if it has shifted. Next, you have to be able to communicate to law enforcement that you're operating, that you're back in operating condition and can handle the rest of the trip, and be able to communicate to them and have them sign off on you continuing your trip. And also, you have to pick up the warning markers and flares, which is not, it's not a trivial barrier to being able to deploy. It's not like you can just shoot a flare off and say, we're good. You have to clean up your mess. And it's one thing to say things happen on the roadway. It's another thing to say, we don't have a plan for this. That is one of those things that will prevent you from ever being able to deploy. So all of these things are just a couple of examples of some of the regulations that must be overcome before you can remove the human driver from the operations of a commercial motor vehicle. Because we always have a human driver present and ready to take on responsibility of the situation, we're able to comply with all these things today and drive the majority of the benefits that autonomous trucking can bring in the near future without having to wait on both the regulatory updates and the technological solution to be able to deploy. And you have to have both things. So we're talking a long time, probably closer to the end of the decade before you can see true driver-out trucking across the U.S. So as we work with the government, as we showcase how we're approaching safety, and as we talk to them about compliance, we've had lots of great conversations with the federal government and our state and local partners, including state highway patrols. One of the ways we're doing this is we want to make sure that we hold no surprises. And there's a benefit to our system in that the way we're approaching things, we're able to communicate much more clearly and go piece by piece and being able to update the authorities on how we're approaching safety, on how we're ensuring we have the right priorities and the right steps in place to assure the safe operations of the demonstration or pilot or ultimately commercial deployment. So one of the things we did recently was release a voluntary safety self-assessment. This is something that the federal government has asked companies do if they're legitimate and if they're serious about deploying at scale, which we are. So Michelle Shaka, who is a safety expert with many, many years of experience, she and I worked together on this. She said all the smart things. I tried to make it more easy to understand, but she's going to be able to go into detail about this VSSA and about how Locomation's approaching safety, because we got a really, really good story to tell. Michelle?
Well, thanks, Fitch. I think you're giving me a little too much credit, but I'm looking forward to walking through all of the different elements that US DOT outlined for companies to look at how they're addressing safety. All right, so this is the table of contents of our VSSA, and it outlines those 12 different safety elements that US DOT set out as guidance and asked companies to explain how they're addressing them and how we're ensuring the safe deployment and on-road testing of our vehicles. And so our VSSA walks through all 12 of these. But maybe before I dive in specifically to some of the areas in the VSSA, I want to talk a little bit further about why it matters and why we recently made this release. So one, it really serves as a marker of our progress. We are really careful to not make any claims on items that we hadn't accomplished. Two, we released it because we wanted to demonstrate our readiness for on-road and public road testing. And so Localmation has begun testing on public roads in Pennsylvania and Ohio, but we have done extensive analysis, simulation, and track testing to get to that point of readiness. And we wanted to share that with the government and all stakeholders. And so this VSSA really helps inform the general public, the government bodies, and other stakeholders on how our technology works, what we're doing to ensure safely what we're doing to ensure that our public road testing is safe and in compliance. And Finch spent a lot of time talking about the regulations, so I won't go into that. And unfortunately, I'd love to have all afternoon to take you through every single detail, but what I hope to do is really entice you to run after this and download our document and read it from page to page. So what I'll do is take you through some of the highlighted areas that I have on the slide today, but I want to reinforce that if there's any questions on any of these topics, I'm going to hand all the hard questions over to Finch, and I'll take all the easy ones, but we're happy to answer any questions that you might have on any of these topics. And so let's dive in to the first one, which really just talking about our overall approach to safety. And so as Finch mentioned, our safety approach, it really starts with being informed by decades of experience in autonomy. Our human-guided solution combines superior cognitive ability of a human driver to navigate the convoy through complex roadway situations with superhuman reaction times and the control precision of autonomous technology to maintain that tight synchronization between the two trucks. So even with our human-guided approach, there needs to be significant rigor in how we engineer, manufacture, operate, and improve our ARC system. So safety really starts with having the right culture. And so what does that mean? It means everyone in the organization is responsible for safety, not just Finch and I, every single employee that works at Locomation. Anyone can report a safety concern without fear of retribution, including initiating a grounding. And so we really encourage people to, if you see something, say something. We want to make sure we resolve any kind of concerns that we find. And so when you talk about having a safe system, it really starts, again, with engineering it right. So making sure that our ARC system is functionally safe at all times. This is both during manual and autonomous operations. And in the presence of significant faults or failures, the system needs to be able to transition to a safe state. So the ARC shall behave predictably to other road users. It's not just us on the road. And the system needs to be evaluated through verification and validation testing. And I'll take you through in the coming slides a little bit more of what we're doing in that area. And so safety doesn't stop with engineering. So you can engineer the best product in the world, but you need to make sure that you manufacture it right. And so this is making sure that your system, as it's being manufactured or assembled, is free from quality deficiencies and defects that could pose an unreasonable risk to safety. And so when the system is deployed, you need to make sure you operate it right. And so the ARC system needs to be operated by only authorized drivers. So these are our trained drivers that Finch mentioned, and I'll talk a little bit more about what we're doing in that training and how we're training those drivers and making sure that they're situationally aware. And so we need to not just train our drivers and make sure that our system is safe and verify it and validate it. We need to also monitor the performance of our human drivers and our ARC system, and make sure that the technology is maintained properly and that we do pre and post trip inspections. And so as the operations are monitored, it's really important that we take the information from these operations and we use it to improve the ARC system. And so the safety of the ARC system needs to be continuously improved, and we need to actively monitor it. And when we find a potential incident, we need to make sure that that is tracked, reported, and resolved, and that we've implemented the appropriate preventative measures. And so one of the things that we've done by creating these safety pillars is it really has given us a comprehensive way to organize our safety case. And so I'll talk a little bit further about what a safety case is for maybe those who aren't familiar with it. And so a safety case is a structured argument, and it's really a structured argument to be able to create the evidence to justify that your system is safe for specific uses and applications. And so this approach isn't just used by Locomation and isn't just used by AV companies, some of the other AV companies. It really is an approach that's been proven effective by other critical safety areas such as nuclear and aviation. And so we're leveraging a standard UL 4600. That is the standard for the safety for evaluation of autonomous products to guide the creation of our safety case. And Locomation is working with a company called Edge Case Research, and they really championed the development of the standard in order to map that standard to our specific application. And so our safety case starts with a top safety claim that's really simple. The ARC system shall be acceptably safe to operate on public roads. So what does this really mean? It means that it needs to be free from unreasonable risk to harm of humans and or property. And so that top, very simple safety claim is then decomposed into several different claims and then organized by those safety pillars that I just walked you through into multiple different kinds of evidence. And I'll try to hit on some of those evidence as I walk through all the different topics that I'm going to go through today. And so when you talk about a system being safe, one of the most important parts is understanding where your system is going to be deployed. And so what is that environment that your system needs to be designed to? So we need to understand how our system is going to be used and what constraints are needed to deploy into that operating environment. And so this slide is actually highlighting some of our current prototype testing, operational design domain limitations. And I'll just give you one example. So speed, our system is limited at 70 miles an hour. And so our vehicles can't go any faster than 70 miles an hour. And that's really important when you're talking about an 8-class truck. And so speed does matter when we talk about safety. And so once you understand that operating domain, you really then can design the technology requirements you need to be able to deploy in that environment. And so our ARC system includes surround sensor coverage and redundancy to complement the guidance of our human driver. And so the ARC system has LiDAR and cameras in the mirrors. It has radars in the bumpers. And very important to our convoy system, we have wireless communications that would enable us to have that really tight following capability that we need and to provide the situational awareness to our drivers. And so Finch was talking about, really our problem set being reduced, and the fact that because we have the human driver to guide the autonomy, all of those different edge cases become a bit more simple. And so a lot of the difficulty, the first 90%, when you think of all the different situations that an autonomous vehicle might experience, most of those are fairly simple. It's really that last 10% that is super duper hard. And so these are highlighting some of the areas and situations that can be quite difficult. And so our human driver serves at that primary detecting and responding of objects and events. And so I'll just highlight one, public service personnel. And so the autonomy technology operator, that's the human driver, they are present there to interact with law enforcement for inspections and emergency personnel, just like drivers do today. And so even though we have a human driver in the loop, it is really important, that doesn't change that we don't need to engage with public service personnel. It's really important that we do that and we make sure that they're aware of how our technology works so they can do their jobs to keep our roads safe. And so, in fact, we had Staff Lieutenant Chris Kinn from the Ohio State Patrol recently visit Locomation at our facility out at TRC in Ohio, where we do a lot of our testing. And so he wanted to come learn more about our technology and our convoy system and our testing plans to make sure that he informed the other highway patrollers that might come across our vehicle. And so when we talk about, our ability to detect and respond to events, the human driver is that primary, as I mentioned, that primary leading that our human guided autonomy. So it's really important that we provide our driver with the information they need to safely guide the convoy. So our approach is really simple. It's designing our human-machine interface, and so that's the driver display that the driver sees, and to create something that's intuitive interface, so it's really straightforward and conveys just the necessary information while minimizing any potential distractions. So their first primary task is doing that driving. And so what you're seeing on the screen today is currently our first generation, and that's continuing to be refined. And so it's not just important that we give our human lead driver the information that they need to drive safely. Our convoy isn't driving alone. Our convoy shares the road with other road users, and we want to provide them with the information they need so they can make sure that they can drive safely. And so our trucks have external indicators and signage. And so our mirror pods have a light indicating that our convoy is operating in autonomous mode. We also have a sign, autonomous link convoys do not cut in between. And we chose this language based on a Federal Highway Administration trucking platoon study. And that study found that if you had signage like this, it was really effective for drivers understanding and comprehending that this was a platoon, and being able to really help accept this technology and understand it. And so, as we think about all of these different situations and what our drivers need to do, one of the most important things is properly managing that space between the lead truck and the follower truck and making sure that it is safe. And so today, when we're testing on the roads, we're testing with a 1.25 second headway gap, so the gap distance between the two trucks. And so one of the things, if you run out and grab the VSSA, which I'm sure you're going to do after this great presentation, and read it from bookend to bookend, you'll find that there is a discussion in there that points to some independent research on the safe gaps for platooning. And so our goal is to reduce that gap down to a half a second. And this independent research found that having that half a second really discouraged other road users from cutting in, and it still provide enough distance to manage critical events. And so even with the signage that I talked about and the close following gap, we still need to be prepared for intruders to cut between our convoy. And so when a cut-in happens, the follower will increase a gap to a safe distance, and then the human driver in the lead truck will be informed. And that human driver can then begin slowing down the convoy or changing lanes. And so one of the important parts that I spend a lot of time thinking about and working on in Locomation is how are we going to validate the system to make sure it's safe. And unfortunately, there isn't one silver bullet that we can do and prove that our system is safe. And so we have to use a whole bunch of tools, because every tool provides a different value in being able to verify and validate our system. And so we have employed a multifaceted testing architecture that includes analytical methods, simulation, closed course, and on-road testing. And so simulation, the first one there on the screen, allows us to simulate a large variety of scenarios in controlled and repeatable and predictable manner to evaluate how our system will perform in some of the most safety critical situations. The closed course testing there in the middle is essential for validating our simulation outputs while also putting our system through conditions similar to those found on the roadway, but in a more controlled and repeatable manner. Finally, the last one, on-road testing, which we're starting to do, will confirm the performance in a real world where there is very limited control and repeatability that the conditions that the system will encounter. And so all of these together will provide Locomation with the necessary evidence to be able to validate that we have achieved an acceptable level of safety. And so even with all of that engineering rigor and all of the testing that we're doing, even with all that rigor that we've done and that I've taken you through all of those different simulation methods and the redundant systems that we have, we need to be prepared for handling faults and failures. And so we aim, in order to do this, we create measures and a fault management system that helps us help the vehicle maintain safe operations. And when we have a fault and failure and it's necessary, we quickly get that vehicle to a safe state. And so the last area that I want to talk about is driver training. Being that we're a human-led system, driver training is the really, really important. And so Locomation takes several steps to make sure our drivers are some of the safest drivers on the road. And so this starts with when they're on board and continues throughout their employment at Locomation. And so we do classroom training, we do on-road training and closed course assessments as well. And we do this to cover all of the driving essentials, to make sure they understand the autonomy technology and that operating design domain that they have shared responsibility to monitor. One of the most important parts of the training is to ensure that the drivers understand that if they have any safety concerns, they need to raise it and that they can ground the fleet without any retribution. So we're continuing to develop this training program and working with our carriers to make sure that that program can be translated to them to make sure their drivers are also some of the safest on the road. And so I think I will end with this. And what I want to say is, me and Finch being here today, this isn't our last word. And so the VSSA that we released, this is really just a first step to make sure that we are being transparent with what we're doing and making sure that our safety is verifiable and that we're meeting with all the stakeholders to make sure that they understand how our system is safe. And so as we move forward to expand our ODD and begin removing our safety driver, we will be releasing another VSSA and doing many more of these kind of webinars to have a discussion. So I'm looking forward to all of your questions and opening it up.
Excellent. Thanks so much, Michelle. As I mentioned earlier, now we have time for questions from the audience, and many of you have already been submitting great questions for us. However, if you haven't already done so, please do go ahead and use the Q&A box in your console. We're going to roll through as many as we have time for right now. So just to start, I love all of these benefits, but how are you answering the question about adding another vehicle of that size to already crowded roadways just to make the system work? Finch, I'll start this one with you.
Sure. So the good news is we're not the only ones that have ever looked at this question. There have been significant studies and pilots that have been done. I'm thinking of some in Illinois and Florida and California in particular that have shown not only can this increase capacity because you can have the two trucks following so closely that they essentially operate as one unit, but that other road users aren't negatively impacted. California is a good example. They have had the state legislature initiate studies to help inform their future rulemakings. I believe they've done over 10,000 on-road miles with University of UC Berkeley, the California Path Group, Volvo, and some others that have generated on-road miles, and they've tested that this not only is safe and they haven't had any crashes, but that other road users generally find it easy to either get around the convoy or essentially slow down and get behind the convoy if they need to, let's say, get to an exit. So they find that it actually has benefits to the efficiency of the roadway systems. You can increase capacity, and it operates as a unit that doesn't really disrupt the other road users. So you may not think that, but when it comes to it, people very quickly understand what's going on, especially with all the external indicators Michelle talked about. An actual on-road test have shown the safety and efficacy of this model. And one thing that I think is worth talking about is it's always a 2-truck linked convoy. And there's a few reasons for that. The technology can do more trucks. We've seen other platooning models where they have more, but it doesn't really make sense when you consider the actual value that these systems bring. We mentioned it before, but the autonomous relay convoy system can achieve 2/3 of the cost savings that autonomous trucks can bring. Someday they'll get there, but we can do this today. And autonomous trucks are thought to be able to bring about 44% of cost reductions for the overall operations of that CMV on that route. Now, one of the things we also talked about is you have to separate the local activity from the line haul activity. That way, you don't end up with all of that detention time that truck drivers today suffer from. So if you're only operating your very expensive autonomous truck, or I think theirs a lot more expensive than ours is, but still, stick with me. If you're adding more money to operate a truck and it's still sitting in detention time waiting to pick up a load or running deadhead miles, you're not finding a more efficient way to do it. And so one of the things that's interesting is our autonomous relay convoy model is can create 28% cost savings compared to conventional operations. So 2/3 of that full 44%. Now, when we bring in our digital transportation solution, and of course we're developing autonomous trucks in the future, we're looking at a fully 50% cost savings that come from this. And one of the things you can't forget is just because you say we're splitting out the local activity from the line haul activity, that doesn't mean you don't have to account for the local activity. So when we look at our full solution with our relay model fully implemented to include local assets, we're looking at a gross savings of 23% and a net savings of 11%, meaning the carrier will see its current profit margin more than double on a much larger portion of business. So as we talk about that, and again, if you're thinking 2 human drivers can get you to 22 hours a day because both human drivers get 11 hours a day to drive, a third driver would only get you 2 more hours. And it adds a number of operational complexities that aren't really necessary because you found where the value is and you've unlocked it. So you don't really need to go further. So the safety's there, the efficiency of the system's there, and the value is there from this. So it is a very effective proposition with no need to make it any more complicated.
Excellent. Next question here is from Bob. What limitations might exist for the type, size, age of equipment on which this can be deployed? What onboard redundancy exists, and are there any environmental conditions such as weather, construction zones, etc., that limit the use? Michelle, I'll start with this one.
Yeah, thanks. I'm really glad Bob asked this question. So there are quite a bit of limitations. This isn't a system that can just be put on any truck. And so we're working really closely with the carriers. So we are using a Peterbilt platform. And so it is a specific model with specific requirements to what that vehicle needs to be ordered to. And so there is a small window of where that equipment and the age of the equipment that it can be used. And as far as the redundancy, there is braking redundancy, steering redundancy, there's redundancy in our sensor systems, not just the fact that we have LiDARs, we have cameras, and that we have radars. We have multiple LiDARs, we have multiple radars, we have multiple cameras. And so it's really, the redundancy is very, very important. We have redundancy in our communication system. And so when we look at the environmental conditions and where this is going to be deployed, it is going to be deployed only on highways. And so that does limit some of the situations or conditions that you might find, things like making a left turn. And so there are several limitations just by limiting the route. And so these are going to be on very specific routes. And we are going to be doing we are doing a lot of analysis to really understand that route using best practices. So looking at all of the different curvature around the route and making sure that as we do the simulation I talked about, that covers every single different curvature that we would maybe find. And so right now we're not testing in construction zones because we have a human guided autonomy. We do plan to do that. We're doing construction zone testing at our test track, but there are some states that have some limitations, but it's fairly easy for our system to be able to be flexible around that because we have the human driver there, so when we need to. As far as weather conditions, right now we're not testing in any kind of rain or snow, but on the roads, but we are doing some of that testing at TRC and plan to have that as part of our domain as we go forward. So thanks, Julia.
Excellent.
And thanks, Bob, really for that question. It was a good one.
Excellent. We've got so many great questions coming in. Next question, we've had a couple of folks ask. James and Liam are both wanting to know, with the recent litigation at Too Simple, do you see this as a possible headwind for regulatory approval moving forward? And James is also wanting to know about whether or not it ever seems like we will have trucks without any drivers in them. Finch, I'll pitch both of these to you.
Some loaded questions. I will say I'm not going to directly talk about a competitor, but I will just talk about the ecosystem as a whole. One thing to keep in mind is actions of other road users and the autonomous trucking industry can definitely impact the regulatory perspective, either making it move faster or delay. One of the things we know is organized labor and some safety advocates are requesting that the National Highway Traffic Safety Administration move forward with the regulations that were started under Secretary Chow for the regulation of the operation of an autonomous vehicle to move forward before the rulemaking that would allow the drivers to be removed from the operation of a commercial motor vehicle. So this would definitely take to closer to the end of the decade. The good news for us is fundamentally that approach, the development of a safety case, is what is envisioned in the regulatory agenda for the future of automated vehicles. We're already doing that. We're doing that for our autonomous relay convoy product, our drone follower product, and for our fully autonomous trucks in the future. We're building the case step by step, and because we already are envisioning these questions and we've got these safeguards in place, specifically safeguards that prevent you from turning on autonomy if the system is not ready. We have a multi-step approach that ensures that the system is actually ready to engage before you can turn it on. So any sort of specific examples that people have in mind, we've already solved for that. We built that in on the front end, and it's because we're following the safety case approach for developing the safety of the system. So yes, other road users could impact it. The FMCSA could decide they're not going to move forward with that rulemaking anytime soon until NHTSA moves forward with their side of the rulemaking. That's certainly what organized labor wants from them. I mean, the good news for us is organized labor generally likes our model because it helps them compete against fully autonomous trucks. It helps their drivers earn more money and become more valuable. And so they've actually seen us, they've supported us in public before. I haven't gotten like any special letters to the secretary or anything saying this is our preferred model. But certainly when they look at their future, they know that if they can use technology to make their truck drivers more valuable, their truck drivers are in a better position in the future. And so we have surprisingly good relationships there. So we'll be okay. Excellent. Even if these rulemakings take a lot longer than you would otherwise think.
Excellent. Next question here is from Jason. Will you be providing the drivers for your clients, or will you be training their drivers? Michelle, I'll turn this one over to you.
Yeah, thanks, Jason, for that question. And so we will be using the carrier's drivers. So they will have and provide the drivers, but we're working really closely. And I talked about the driver training. And so we're doing a lot of work of evaluating that training with our drivers. And so we have hired experts, truck drivers that have been driving trucks for decades and have lots and lots of experience. And so we're working directly with them and people that have specialties in developing educational material to develop our training and validate that through our processes. But we're working very closely with the carriers to make sure what we're developing will work for them. And so while it'll be our carriers doing the training and their drivers, we will be closely involved and make sure to be monitoring that process and continuing to improve it, because our goal is to have the safest drivers on the road.
Wonderful. Next question here from Joseph. What infrastructure will be needed to develop in order to handle the increased capacity automated platooning will provide? Finch, I'll turn this one to you.
So there's no particular infrastructure that's needed beyond good safe bridges, good visible signage and striping, and of course the yards that you need to begin and end that customers and carriers can own, or that can otherwise be managed with the route itself. In many cases, it just so dramatically simplifies the operation of a commercial motor vehicle to have a human driver on duty leading the lead vehicle, because they can handle all of the situations that a normal driver can handle today. And so there's not all that much special that's needed. There's not any roadside infrastructure that's needed to maintain the connection between the two platooning vehicles. That's handled with onboard units that use vehicle-to-vehicle connectivity to control the distance between the vehicles. So there's not a whole lot extra that's needed beyond your basics of what's needed for a trucking operation.
Excellent. Next question here. What about fueling? How would driver 2 not be in service and not driving? Finch, I'll let you carry on with this one.
Yeah, this is actually also relatively straightforward when you look at the day in the life of a trucker, which is something we've done to make sure that we're thinking through all the challenges. So there's a few ways this can be handled. The simplest is a human driver is allowed to drive for 7 hours before they need to take a 30-minute break. So as we look at using the team driver approach, this can be an area where we would seek to do that at a pilot station. They'd get out, they'd refuel, and then when they get back in formation and get on the road, you now would have the drivers switching places. So the person who was the lead driver is now in the following vehicle, or the truck switch places. So the truck is now following, and that person's in the sleeper berth, relieved of all responsibility for the operations of the vehicle, saving their hours. Now, there's also a way we could do it to where you pull in formation at a gas station, and the lead driver just pulls up, fuels the vehicle, fuels the following vehicle, and they keep going. But you probably plan in the fueling in the organization of the route so that you can stay in compliance with hours of service time anyway. So there's multiple ways to cook an egg. It's just whichever one you want that day.
Great. Next question here is from Dan. What are the autonomous relay convoys' capabilities in terms of being able to handle highways, local roads, cities, etc.? Michelle, I'll let you take this one.
Yeah, so I think I might have answered this one a little bit in that last question, but our operating domain is just a highway situation. So that is going from rest stops and merging on, but it only includes the highway. And so we're not looking at anything else beyond and outside of the highway right now today.
Excellent. Next question is from David. David asks, wouldn't you need the second driver to be able to go directly to the sleeper berth to start? Finch, I'll let you take this.
That's a super good question. In general, the answer is yes for now. So that driver needs to be, when you start the convoy, you can start it where you have the trucks essentially lined up and ready to go. When you've done all the checks and you're ready to start the route, that following driver would go immediately to the sleeper berth so that they can be relieved of all responsibility and start their rest time. Now, in the future, there could be a situation where we'd have the trucks on the road and conduct that, but have the driver go in the back when the vehicle is moving. But we're not going to start with that. So that's sort of beyond the scope. So right now we are planning to start autonomy from a standstill, have everything lined up, all the checks done, ready to go before we start that route. So they would start out in the sleeper berth.
Excellent. Next question here is from Kent. Generally, for human drivers at 55 miles per hour, it's recommended to have 6 seconds between vehicles. The 1.5 seconds between your leader and follower, does that change based on loaded or unloaded trucks, weather conditions, etc.? Michelle, I'll let you take this one.
Yeah, so when I was talking about the half a second gap, I was talking about very ideal conditions. And so there is quite a bit of work that we need to do to manage that gap and quite a bit of testing. And so Kent is right that it does change based on the loading of the vehicle. And so those of you who are familiar with trucks will realize that 40% of the braking comes from that trailer. And so we really do need to understand that and be able to manage that gap based on that. And so when there is rain happening, that gap might need to be opened. And so it will be based on speed and weather conditions and loading. That will all be part of managing that gap. And so there's quite a bit of testing and analytics and simulation that goes into developing, that right gap and managing that gap. So I really appreciate that. And, I just have a 16-year-old, and I just taught him about making sure to have that proper 6 seconds between vehicles. One of the things I should mention is it really has to do with our V2V communication and being able to almost instantaneously know when the leader is beginning to break. And so that technology, which Locomation has quite a few patents on, is really the enabling technology for us to be able to close that gap. And so we're not waiting for the perception system, so those cameras and LiDARs to be able to perceive that the brake lights of the front truck are beginning to go on. We're getting that through that V2V communication. So immediately, once that brake pedal begins to press, that information is being communicated to that follower truck. So we're immediately following that, what the leader is doing. So very, very good question. Thanks.
Excellent. We've got time for just one or two more questions, but I did want to let everyone know if we aren't able to answer your question live, please still know that we will be happy to follow up with you offline. So continue to go ahead and send in all of those questions. Next one here is from Dan. If a driver needs to step in to manually assist, how does that impact their hours of service, and how's that tracked? Finch, this one's for you.
Certainly. So obviously we organize it in every way possible to try and ensure that the human driver in the following vehicle doesn't have to take any actions if they're supposed to be in the sleeper berth. And it's very important to know that there is no situation where if a driver is in a sleeper berth relieved of all responsibility, we would not ever expect them to wake up and go jump in the driver's seat and figure out the situation right away. That is fundamentally unsafe, and that is not the way we're going to do it. But let's say something happens and they have to pull the convoy over, and they decide, we need to wake up the following driver. Let's say somebody else hits the lead truck or whatever, but the following truck is otherwise ready to go. They'd wake up that driver, their hours of service would come back on, and they would just be limited to a normal day's work and how they can complete the route. One of the benefits of the system is it's incredibly flexible, and that if you have crazy things that happen on the road, you still have, in some situations, if you're on a long haul route, 2 human drivers present. Otherwise, if you're on a short haul route, you can still have a situation where you have 1 human driver and 2 trucks. But it's all about staying in compliance with normal hours of service. So if they are no longer relieved of all responsibility, then they are back on the clock.
Excellent. We've got time for just one more question. So last one here is from Diego. How do you operate in states in which the required gap distance is greater than ideal, meaning the increased chance of vehicles getting in between the leader and the follower? Michelle, I'll turn this one over to you.
This may be more of a Finch question, so I hate to cut you off, Michelle.
Go for it.
But this is some of the day in the life stuff that I get to live. So we've actually been talking to a ton of states across the country. In the majority of the states, they either explicitly allow connected and automated vehicle technologies that can allow following distance to be much closer than otherwise. For us, that's up to half second or 50 feet behind the vehicle. There's 6 states that have specific numbers still. The majority of them have looked at this technology and they've taken steps to update their regulations. So you're talking about 6 states out of actually 51 as we count it. And one good example is California still has their old following distance on the books, but it's because the state legislature said, go study this question and see if it's safe. And as I've mentioned, they've produced 2 reports. The third and final report is coming out within the next 12 months. I believe it's the beginning of 2023. And as of the last report, they had already done 10,000 miles safely, legally and routinely across the state and seen benefits. So California is a good example of, they just said, well, let's conduct a study with our universities before we update the regulation. But we expect that regulation to be updated in 2023 because of all the positive things we've seen. So it's limited in states that still have those old provisions. And we're working in those places to make sure that the regulations are updated to accommodate the latest safe approaches.
Excellent. Thanks for that.
Can we give Michelle one more question since I stole her final one?
I would love to. Unfortunately, that is all the time we have for today. Finch and Michelle, you have both been fantastic presenters, and our audience, thank you all so much for participating. We've had some great questions coming in, and as I mentioned, we would love to follow up with you offline. Thank you, of course, to Locomation for partnering with us for today's presentation. And as I mentioned earlier, we will be sending a link to the recording of the webinar tomorrow via the email that you used to register. We hope you'll join us again next time for another FreightWaves webinar. Thanks, everyone.
Thanks for having us.
Thanks, Julia. Thank you.